Hello, in this video, we are going to just go through chapter 2 very quickly and review a couple of things from Regents Chem and talk about a few new things such as mass spectroscopy. We'll talk a little bit about naming polyatomic ions and naming acids. Again, we are going to be reviewing a lot of topics that we covered in Regents Chem, such as naming compounds. Make sure you look over the summer assignment materials on the Google Classroom, even though a summer assignment was not required this summer. It would have been better off for you to do it over the summer instead of trying to cram it into the next couple of days. In Regents Chemistry, we did not talk about a mass spectrometer. A mass spectrometer is an instrument, a very expensive instrument that is used to determine the atomic mass of an element. The particles are separated in there according to their mass. So if we have a pure element, it will show us how many different isotopes are present and also the approximate abundance of each isotope, and then you could figure out the average atomic mass of that element. For example, this one shows us the mass spec of chlorine. So we see by looking at this, we have two different isotopes since we have two peaks there. We see that the mass of 35 is about 75% abundant. So if we were figuring out the weighted average atomic mass, we would do 35 times 0.75. Then the isotope 37, that one's about 25% abundant. So we would do the math and get the average atomic mass, which would come out to be just about 35 and a half for chlorine. Looking at your periodic table right now, there are some names that we need to know. The group 1 metals are also called the alkali metals. So we need to know that alkali means group 1, sodium, potassium, and so on. And they all tend to form +1 ions because they all have one valence electron, so they'll lose the one valence electron to get to 8. The group 2 metals, so magnesium, calcium, they are the alkaline earth metals. And when they form ions, they have two valence electrons, which they'll lose, so they form +2 ions when they make ionic compounds. Group 17, we should already know that those are called the halogens. So we got fluorine, chlorine, bromine, iodine. They tend to make -1 ions when they react because they have 7 valence electrons, so they'll gain 1 to get to 8. And then group 18 are noble gases. Those are pretty much unreactive because they already have a full valent shell, so they will not form ionic compounds. And then groups 3 through 12, remember, those are the transition metals. And they can have some various ionic charges depending on what it is. Like iron can be +2 or +3, copper can make +1 or +2 ions. All right, now for the main part of our video, naming polyatomic ions. When we were in Regents Chemistry, we had a reference table E, that gave us the name of our common polyatomic ions. We now need to memorize those, but it is not as daunting of a task as it appears. So if you look at the list, you're like, oh wow, there's a lot for me to memorize. Not really. You have to memorize a couple of common ones and then some rules on how the rest of them are derived. So first off, an oxyanion is a polyatomic ion that contains oxygen. And its names will end in "ate" or "ite", like sulfate, sulfite, nitrite, and so on. 8 is used for the most common form of that oxyion. So if we have NO3 minus, that is the nitrate ion. So we have to remember that NO3 minus is nitrate. Then 8 is the same form, but with one less oxygen. So if NO3 minus is nitrate, NO2 minus would be nitrite. We'll look at another example. Sulfate is SO4 minus 2. So again, most common is 8, so you do need to memorize the 8 one. So SO4 minus 2, sulfate. We also have sulfite. Since it ends in ite, it would have one less oxygen, but still have the same charge. So we really need to memorize the most common form, the sulfate, and then just know the rules at how to derive the rest of them. Now, sometimes we also have some prefixes that can be used too. So we'll see two different prefixes, per and hypo. Per indicates one more oxygen than the common one, than the 8 form. So think about per is somebody who's perfect and they are an overachiever, so there's an extra O. Hypo has one less oxygen than the ite form. So, for example, chlorate here. So ClO3 minus chlorate. That's the one we have to memorize because that's our common one. So we have perchlorate. Perchlorate would have one extra oxygen than the 8 one. So it's ClO4 minus, but still the same charge. We talked about ite on the previous slide. That means one less O than the ite, so ClO minus. So if we know the chlorate series, so chlorate, ClO3 minus, that's the common one. Then we would also know perchlorate, one extra. We would know chlorite, one less O, and hypochlorite, one less than that one. Now we know that chlorine is going to behave the same way that all of the other halogens do. So if we know chlorate, we also know the bromate, fluorate, and iodate series. So you can simply substitute one halogen for the other because they all have seven valence electrons, they'll all bond in a similar fashion. So really the only polyatomics that we need to memorize are these ones here. So hydroxide, OH minus, signifies we have a base. Sulfate, SO4 with a minus 2 charge. Nitrate, NO3 minus 1. Phosphate, PO4 minus 3. Chlorate, ClO3 minus. Acetate, we could write that one two different ways. So you could see it written as CH3, COO minus, or C2, H3, O2 minus. It's the same thing. Hydronium, we should also know that one from acid base. That signifies an acid. H3O plus, ammonium, NH4 plus, and cyanide, CN minus. So we need to memorize those ones. And then we need to know how to be able to derive some of the other ones from there. So from nitrate, we need to be able to do nitrite. It ends in ite, so there's one less O, so NO2 minus. Sulfate is one of our common ones, so we just have to know that one, SO4 minus 2. Sulfite, ite, one less O, so SO3 minus 2. Then we have chlorate, so that's ClO3 minus. Ite would be 1 less O, ClO2 minus. Hypochlorite is 1 less than the ite, so ClO minus. Perchlorate, perfect overachiever, 1 more than the 8 form. And then if we know the chlorate series, we know the bromate, fluorate, and iodate series. Okay, one that was not on my previous slide, carbonate, CO3 minus 2, and hydrogen carbonate. That's going to literally be the hydrogen ion plus the carbonate ion. So here the charge will change because we're adding in an ion. So now it's going to be HCO3 minus because we're doing the H plus ion and the carbonate ion. And then cyanide, CN minus, and thiocyanate has the sulfur atom in there. And this one here, we don't really have to memorize, but it does show up, so it is nice to know. But the rest of them we do certainly need to know. So we'll do a couple of quick naming examples. So let's say we have iron, Roman numeral 2, sulfite. Okay, so iron, Fe. The charge on that iron would be plus 2. Sulfite would be SO3 minus 2. And then we would crisscross and those would reduce. So it would just be FeSO3. If it was plain sulfur, the monatomic ion, it would be sulfide. All right, example number 2. Ammonium phosphide. Okay, so ammonium, one of our polyatomic ions, NH4 plus 1. Phosphide, it's not a polyatomic, just phosphorus. Phosphorus has 5 valence electrons, so it would make a minus 3 ion. So then it would be NH4, 3, and P. All right, last example, we will do copper, 2 phosphate. So copper can be plus 1 or plus 2. Since we have Roman numeral 2, it is plus 2. Phosphate is one of our polyatomics, PO4 minus 3. When I crisscross those two, I get Cu3, PO4, 2. Last thing is naming acids. Now, in Regents Chemistry, we were lucky enough to be given a table that had some of the names of our common acids on there. We now need to name them. But honestly, once you know your polyatomics, it's not bad, and you can work off of names that you already know. So it's all based on our anion's name, the negative ion's name. So if we have a binary acid, meaning we simply have 2 elements, we have to have hydrogen, so hydrogen plus a negative ion, then you want to think about hydrochloric acid. So our most common acid that we use in lab, HCl, hydrochloric acid. So if we have HBr, it would be hydrobromic acid. If you had H with sulfur, it would be H2S, and it would be hydrosulfic acid. So you just want to follow this example and substitute the anion's name in there. All right, if we have a polyatomic ion, again, you can think about some of the things that you already know, like HNO3 is nitric acid. HNO3 comes from the hydrogen ion and the nitrate ion. So if it had ended in 8, you change the ending to ic and then add the word acid. So if you have H2SO4, that comes from the sulfate ion, so it's sulfuric acid. If the anion ends in ite, like nitrite, then you change it to OUS, so nitrous acid. So I had a student a few years back that came up with this saying, at night, acid dealers are dangerous, to help us remember the OUS. Obviously, we realize that night is not spelled correctly, but it worked for our example. And then we also came up with you ate to something icky to remember that 8 changes to ick. So as a summary, if you just have a plain monatomic anion like chloride, then it becomes hydro, whatever the anion is, ic acid. But the easier way to remember it is just hydrochloric acid. Then if you have an anion that ends in 8, like nitrate, it becomes nitric acid. So it just becomes blank ic acid. So chlorate, chloric acid. If you have a polyatomic that ends in ite, like chlorite, it changes to OUS and you add in the word acid, so chlorus acid. So we'll just run through a couple of quick examples here. So example 1, HBr. That would be like HCl. So HCl is hydrochloric acid. So this would be hydrobromic acid. Okay, then we could have it with the polyatomic ions. So BrO3 is bromate. So therefore, this would become bromic acid, just like sulfate is sulfuric acid or nitrate is nitric acid. Now we also have perbromate. If it's with the H, then it would be perbromic acid. So same thing, it just has the per on there. Okay, then we could also have HBrO2. BrO2 would be bromite, so then it would be bromus, because the ite becomes OUS, so bromus acid. And then lastly, HBrO. BrO would be called hypobromic. So this would now be hypobromus acid.